Welcome to TLC Math Made Easy. This video is all about proportions and proportionality theorem. So, what are the objectives of this video? At the end of the session, you should be able to describe a proportion and apply the fundamental properties of proportions to solve problems involving proportions. Recall that the ratio of two numbers A and B should not be equal to 0 is the number A is to B, which may be written as A over B. So in the figure, the ratio of AB to BC is AB over BC, and that is, since AB is 3 units and BC is 1, 2, 3, 4, 5, 6 is 6 units, then the ratio of AB to BC is 3 over 6, or in simplest form, that is 1/2. Also recall that the equality of two ratios A is to B and C is to D forms the so-called proportion. A over B is equal to C over D. So remember that in a proportion, two ratios are equal. Each number in a proportion is called a term. So A is the first term, B is the second term, C is the third term, and D is the fourth term. And we call B and C, we call the second term and the third term as the means. Those are the second term and the third term. And the first and fourth term are what we call the extremes. So those are the first and the fourth term. So we have the means, B and C, and the extremes, A and D. In geometry, proportions are very useful in solving problems involving lengths of segments. It is often necessary to rewrite a proportion into its equivalent form. And this can be done by using the properties of proportions. Now let's take a look at each property of proportions. The first one is the means extremes product. In a proportion, the product of the means is equal to the product of the extremes. If AB or if A over B equals C over D, then AD is equal to B times C. Or this is just the cross multiplication. A times D is equal to B times C. So for example, find the value of x in the proportion 3 over x equals 9 over 12. So we get the product of the means and the product of the extremes, and then equate these products, or simply cross multiply x times 9, the means, or that is 9 times x, is equal to the product of the extremes, 3 and 12. So 3 times 12. 9 times x is 9x. 3 times 12 is 36. To solve for x, we divide both sides by 9. So we get x is equal to 4. So to check whether your answer is correct, we substitute 4 to x, so 3 over 4 equals 9 over 12. So by cross multiplication, 3 times 12 should be equal to 4 times 9. 3 times 12 is 36, 4 times 9 is also 36. So therefore, your answer wherein x is equal to 4 is correct. The second property is the alternation property. Interchanging the means or interchanging the extremes results in an equivalent proportion. So if given, if A over B equals C over D, then A over C equals B over D, or D over B equals C over A. Again, A over C is equal to B over D, or D over B equals C over A. Let's see. 3 over 4 equals 9 over 12. So if we check that, 3 times 12 is 36, 4 times 9 is 36. Let's see if alternation property will result to equivalent proportion. We have A over C, that is 3 over 9. Will it be equal to B over D, 4 over 12? Now, if we write 3 over 9 in lowest term, 3 over 9 is 1/3, and 4 over 12 in lowest term is also 1/3. So, therefore, it resulted to equivalent proportion. In the same way, D over B, that is 12 over 4, should be equal to C over A, 9 over 3. And 12 over 4 is equal to 3. And 9 over 3 is also equal to 3. So, it resulted to equivalent proportion. The third one is the inverse property. If the terms of the ratios of a proportion are inverted, the result is an equivalent proportion. If A over B is equal to C over D, so we get the inverted terms. B over A is equal to D over C. B over A is equal to D over C. Again, let's take a look at 3 over 4 equals 9 over 12. We know that this given is a proportion. So, let's see if we get the same or equivalent proportion if we write 4 over 3 equals 12 over 9. Are they still equal? 4 over 3 and 12 over 9. 4 over 3, is it equal to 12 over 9? 12 over 9 in simplest form is 12 and 9 are both divisible by 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. So 4 over 3 is equal to 4 over 3. We're now down to the fourth property, which is the addition property. It states that if A over B equals C over D, then A plus B over B equals C plus D over D, where B and D should not be both equal to 0. Now, let's use this property to solve for x in the given. So, 5 over 4 equals 3 over x. So, we get 5 plus 4 over 4 equals 3 plus x over x. And by cross multiplication, 5 plus 4 is 9. So, 9 times x equals 4 times 3 plus x. So, 9 times x is simply 9x. By the distributive property of multiplication over addition, 4 times 3 is 12. 4 times x is 4x. By the addition property of equality, we get 9x. Positive 4x becomes negative 4x is equal to 12. And 9x minus 4x is 5x equals 12. So, to solve for x, we divide both sides by 5. So, therefore, we get x equals 12 over 5. Next, if we have addition property, we also have the subtraction property. If A over B equals C over D, then A minus B over B equals C minus D over D, where B is not equal to 0 and D is also not equal to 0. So let's use this property to solve for x. So we have x plus 1 minus b, that is x plus 2, over b, which is x plus 2, equals 2 minus d, that is 3, over d, which is also 3. So when we simplify x plus 1 minus the quantity x plus 2, so we can cancel out x and x, that is 0. 1 minus 2 is negative 1 over x plus 2, equals 2 minus 3 is negative 1 over 3. By cross multiplication, we get negative 1 times x plus 2 equals negative 1 times 3. So negative 1 times x is negative x, negative 1 times 2 is negative 2, equals negative 1 times 3 is negative 3. So we get negative x, transposing negative 2, that becomes negative 3 plus 2. So we have negative x equals negative 3 plus 2 is negative 1. So dividing both sides by negative 1 to solve for x. So we get x equals negative 1 divided by negative 1 is positive 1. So to check, 1 plus 1 is 2, 1 plus 1 is 2, 1 plus 2 is 3. The last property is the numerator-denominator sum property. If A over B equals C over D equals E over F, then A plus C plus E equals D over B plus D plus F is equal to K, where K is a constant of proportionality. Now let's use this property to solve for x in the given. 2 over x equals x over 18. So we get the numerators 2 plus x over the denominators x plus 18 is equal to 2 over x. So by cross multiplication, we get x times 2 plus x equals 2 times x plus 18. So by DPMA, distributive property of multiplication over addition, x times 2 is 2x, x times x is x squared, equals 2 times x is 2x, and 2 times 18 is 36. Now combining similar terms, we get 2x, this becomes negative 2x, plus x squared equals 36. 2x times minus 2x is 0. So what's left is x squared equals 36. And by extracting the roots, we get square root of x squared is x. Square root of 36 are positive and negative 6. So to check whether our answer is correct, we just substitute the values to the given. So 2 over, when x is equal to 6, 2 over 6, will it be the same as or equal to 6 over 18? 2 over 6 in simplest form is 1/3, since 2 and 6 are both divisible by 2. 6 over 18, 6 and 18 are divisible by 6, so 6 divided by 6 is 1, 18 divided by 6 is 3. So therefore, 1/3 is equal to 1/3, so therefore, our answer is correct. Proportions are used in a number of geometric problems. Some of these are illustrated as follows. The proportionality theorem. If a line intersects two sides of a triangle at distinct points and is parallel to the third side, then the line divides the two sides into two proportional segments. In the given, we have the triangle ABC. Triangle ABC. And we have the line DE. DE intersects the sides AB and AC at points D and E. Then the line, since if DE is parallel to BC, DE is parallel to BC, then the line divides the two sides into two proportional segments. To illustrate this, or to have a better understanding of this, we have, if DE is parallel to BC, the following proportions can be derived from the given figure. So we have the upper left, that is AD, lower left is DB, whole left is AB. We have the upper right is AE, lower right is EC, and then the whole right is AC. So we can derive the following proportions. We have the upper left, that is AD, over the whole left, that is AB, which is equal to base 1 over base 2. So DE over BC. We also have the upper left over whole left, AD over AB is equal to upper right, AE over the whole right, AC. Next, we have the upper right over the whole right equals base 1 over base 2. So upper right, AE over whole right, AC equals base 1 DE over BC. What else? We also have upper left over lower left, AD over DB equals upper right over lower right, AE over EC. Or it could be lower left over whole left, and then lower right over whole right. So those are the possible proportions that can be formed from this figure. Let us now use the properties or the proportionality theorem to solve for the given figure. In triangle ABC, DE is parallel to BC. DB is 24, AD is 16, EC is 12, and AE is missing. We don't know what the value of AE is. So DE is parallel to BC. So we can use the upper right or upper left over lower left. That is AD over DB equals upper right AE over EC lower right. So by substitution, we have AD is 16, DB is 24. equals AE over 12. So by cross multiplication, we have 24E or 24AE equals 16 times 12. And 16 times 12 is equal to 192. So to solve for AE, we divide both sides by 24. So 192 divided by 24 is equal to 8. So therefore, AE is equal to 8. Is this understood? Using the same figure, given is that DB or DE is again parallel to segment DE is parallel to BC. And then we have DB is equal to x plus 1, AD is equal to 28, AE is equal to 21, and EC is equal to 12. So there are many possible proportions that can be formed. So we can use AD over, again, AD over DB equals AE over EC. So by substitution, we have 28 over x plus 1 equals AE, that is 21 over 12. So by cross multiplication, we get 21 times x plus 1 equals 12 times 28. So 21 times x is 21x. 21 times 1 is 21. So plus 21 equals 12 times 28 is equal to 336. We get 21x by the addition property of equality. 21x is equal to 336 minus 21. So we get 21x equals 336 minus 21 is 315. So to solve for x, we divide both sides by 21. So therefore, x is equal to 315 divided by 21 is 15. So x is equal to 15. The converse of the proportionality theorem. The converse of the proportionality theorem states that if a line intersects two sides of a triangle at distinct points and divides the two sides into two proportional segments, then it is parallel to the third side. So, if DE divides the two segments AB and AC into two proportional segments, then DE is parallel to BC. Now, a corollary to the previous statement. When you say corollary, is a proposition that follows from one that is already proven. So what does it say? If three or more parallel lines are cut by two or more transversals, then they intercept proportional segments on these transversals. So we have AB is parallel to CD and EF. So we can write that as AB, segment AB is parallel to CD and parallel also to segment EF. And these parallel lines are cut by the transversals AE. Or let's say this is L and this is M. So therefore, we can say that they intercept proportional segments on these transversals. So we can form proportions from this figure. We can say that AC over CE is equal to BD over DF. Or it could be AC over AE is equal to BD over BF. Could also be CE over AE equals DF over BF. Alright? Now let's use these properties to solve for the following figure. In the figure, AB is parallel to CD and parallel to, or segment AB is parallel to segment CD and parallel to segment EF. If AC is equal to 4, so let's say this is 4, CE is X, BD is 12, and DF is 10. So find X. So what proportion shall we use to solve for X? So we get AC, we have AC over CE equals 12 BD over DF. BD over DF. So AC is 4, CE is X equals BD is 12 and DF is 10. So by cross multiplication, we have 4 times 10 and X times 12. So 12X equals 4 times 10 is 40. So 12X equals 40. To solve for X, we divide both sides by 12. So we get X equals 40 and 12 are divisible by 4. So 40 divided by 4 is 10. 12 divided by 4 is 3. So therefore, X is equal to 10 over 3. Again, we use the same figure. AB is parallel to CD and parallel to EF. If AC is 24 minus X, so this is 24 minus X, CE is X, BD is 18, DF is 9. Find X. Can we use different proportion aside from AC over CE and B equals BD over DF? Let's try two proportions. Let's see if we will arrive at the same answer. Let's use first AC over CE equals BD over DF. So AC is 24 minus X over CE is X, BD is 18 over DF is 9. Since 18 can be divided by 9, we can write that as 24 minus X over X. 18 over 9 is simply 2. So to remove X here, we multiply the whole equation by X. So we get 24 minus X equals X times 2 is 2X. So combining similar terms, we get 24 equals negative X becomes positive X. So 24 equals 2X plus X is 3X. So to solve for X, we divide both sides by 3. So therefore, X is equal to 24 divided by 3 is 8. So let's see if we get the same answer by using different proportion. Let's say AC over AE equals BD. So since this is AE, we use BF over BF. Since AC is 24 minus X, AE is the sum of AC and CE. So we get to get the sum of 24 minus X and X equals BD is 18 and BF, this one is 18 plus 9. So that is 27. So we can simplify this one. Negative X plus X is 0. So what's left is 24 minus X over 24 equals 18 over 27. We can also simplify 18 and 27. They are both divisible by 9. So this becomes 24 minus X over 24 equals 2 over 3. So by cross multiplication, we have 3 times 24 minus X equals 2 times 24. So 3 times 24 is 72 minus 3 times X is 3X equals 2 times 24 is that correct? 2 times 24, 48. Now combining similar terms, let's move here. We get negative 3X is equal to 48 minus 72. So 48, we transpose 72 here, that becomes negative 72. So 48 minus 72 is negative 24. So dividing both sides by negative 3, so we get negative 24 divided by negative 3 is positive 8. So did we get the same answer? X is equal to 8 and X is equal to 8. So yes, we get the same answer using different proportions. I hope that you learned from this video. Thank you for watching, and please don't forget to like and subscribe to our channel TLC Math Made Easy. Thank you everyone, and God bless.